Hello students, this is Sekhar. Now in this video I am going to discuss about what are the questions that are given with the wrong key in the recently conducted Assistant Executive Engineer post examination conducted by Telangana State Service Commission examination. There are about 10 questions that are I have found out with the keen inspection of the paper. పేపర్ని బాగా థరోగా స్టడీ చేసిన తర్వాత నాకు ఒక 10 క్వశ్చన్ల వరకు రాంగ్ కీ ఇచ్చారని చెప్పి నాకు అర్థమైంది. ఏవైతే 10 క్వశ్చన్స్ ఏవైతే ఉన్నాయో స్టూడెంట్స్ దట్ కెన్ బి దీస్ క్వశ్చన్స్ దే మే ఛాలెంజ్ ఇన్ ద సర్వీస్ కమిషన్ వెబ్సైట్ ఆర్ పోర్టల్. ఓకే, మొత్తం మీద 10 క్వశ్చన్ల వరకు నాకు రాంగ్ కీ ఇచ్చారని చెప్పేసి ఐ ఫౌండ్ అవుట్. ఓకే, ద వెరీ ఫస్ట్ క్వశ్చన్ ఈజ్ రిగార్డింగ్ ద హీట్ ట్రాన్స్ఫర్. The very first question is regarding the heat transfer. Look at this. In this question he has given 1D, critical Reynolds number for the sphere. Okay, critical Reynolds number for the sphere, but that is wrong. For sphere, for flow over sphere, that is whenever there is a sphere, whenever there is a flow is happening, the flow is laminar if Reynolds number is less than 2 into 10 power 5, where the Reynolds number is given by Vd rho by mu, where V is the velocity, rho is the rho and mu are the properties of the fluid that is flowing on the sphere. D అనేది characteristic dimension, that is the diameter of the sphere. Any fluid, whenever it is flowing over the sphere, the flow would be laminar if the Reynolds number is less than 2 into 10 power 5 for this spherical flow over space. So that is wrongly, the answer is itself is not there. He has given 1D, but there is no option. Okay, one more thing wrong is given in the same question. Critical Reynolds number for a parallel plate, that is 2C is given, that is 1000. That is again wrong. Whenever there is a flow taking place over a flat plate, this is called parallel flow over a flat plate. This is a fluid flowing. The entire flow will be laminar. Flow is laminar over flat plate if Reynolds number is less than or equal to 5 into 10 power 5, which is also called as the critical Reynolds number. These Reynolds numbers are known as critical Reynolds number because once the Reynolds number crosses this value, the flow entry into the transition, and if the Reynolds number is further higher, the flow would be entry into the turbulent regime. So both are wrong. So these two I can say 1D is wrong. We can straight claim that, and 2C option is also wrong. 2C, that is also wrong. These two options are clearly wrong options that are mentioned in the examination. Definitely people could challenge them, and I am giving the source from where I got this data. We can see here I am giving the data also. The heat transfer textbook, heat and mass HMT textbook written by Sengil and Ghazar in the chapter 7th chapter. The source we may note down, HMT textbook by Sengil and Ghazar, 7th chapter, pages 422 to 430. So I repeat once again, both the options are wrong options based on the source given by the heat and mass transfer textbook written by Sengil and Ghazar, McGraw-Hill publications. Publication is McGraw-Hill. McGraw-Hill publications are standard, and in fact this is a textbook even followed in IITs also for the heat and mass transfer subject. 7th chapter, pages 422 to 430. So that is the source for this, for mentioning these two options are wrong. Okay, so people or students are definitely can note down this textbook for the first question. Source is Sengil and Ghazar. Next question will be for which of the following principles, in fact for which of the following processes the internal energy becomes, this is correct only, in fact this is not wrong, this is correct only. Which of these two statements is true? In reaction turbines, fluid is partially partially expanded in the fixed blades and the remaining expansion takes place in the moving blades. That is correct. But the relative velocity increases in the fixed blades. That is wrong. You see, in the reaction turbine, in the reaction steam turbine, best example is Parsons turbine. Parsons turbine, in the reaction steam turbine, as the steam passes through the nozzles, which are also called as the fixed blades. Nozzles or fixed blades, we can say anything. The relative velocity concept will not arise. In fact, we talk about the relative velocity only in case of the moving blades. Relative velocity increases in the moving blades. The question itself wrongly set. Question itself is wrongly set. There is no concept of relative velocity in the fixed blade. When you talk about the relative velocity, the concept comes only in the moving blades. So in the fixed blade, what velocity will increase? Absolute velocity will increase. Absolute velocity of steam will increase in the fixed blade. V2 is greater than V1. Incidentally, in the moving blades, what velocity will increase? Relative velocity will increase in the moving blade. So, either here in place of fixed blade, there must be moving blade answer, or they should give in the option B, absolute velocity increases in the fixed blade. Either if relative badaluga absolute ichina, option correct. Leda moving blade lo fixed badaluga relative fixed blade badaluga moving blade and ichina koda, the option is correct. So, I can say this base statement B is wrong. Statement B is wrong. The source is Pekenog power plant engineering by Pekenog. Power plant engineering by Pekenog, 7th chapter, 3rd section, 2nd topic. Pekenog by power plant. Okay. Power plant engineering by Pekenog. He has given that, that is a source for this telling that this question is wrong. Actually, ఈ క్వశ్చన్లో చెప్పాలంటే ఇక్కడ రిలేటివ్ వెలాసిటీ బదులు అబ్సల్యూట్ వెలాసిటీ ఇచ్చినా లేదా ఇక్కడ ఫిక్స్డ్ బ్లేడ్ బదులు మూవింగ్ బ్లేడ్ ఇచ్చినా కూడా ఏది ఇచ్చినా ఆప్షన్ బి కరెక్ట్ అయి ఉండేది. బట్ హీ హాస్ గివెన్ ద ఆప్షన్ బోత్ ఏ అండ్ బి ఆర్ ట్రూ. రాంగ్ అండి. ఓన్లీ ఏ ఈజ్ ట్రూ. రియాక్షన్ టర్బైన్ కరెక్ట్. ఫస్ట్ స్టేట్మెంట్ ఈజ్ కరెక్ట్. ఓన్లీ ఏ ఈజ్ ట్రూ. ఫోర్త్ ఆప్షన్ ఈజ్ ద కరెక్ట్ ఆన్సర్. సో థర్డ్ ఆప్షన్ ఈజ్ ద రాంగ్ ఆన్సర్ బికాస్ బి ఈజ్ నాట్ కరెక్ట్. బి ఎప్పుడు కరెక్ట్ అయి ఉండేది? రిలేటివ్ వెలాసిటీ బదులు అబ్సల్యూట్ వెలాసిటీ ఇచ్చినా లేదా ఫిక్స్డ్ బ్లేడ్ బదులు మూవింగ్ బ్లేడ్ ఇచ్చిన. మూవింగ్ బ్లేడ్ లోపల ఎందుకు రిలేటివ్ వెలాసిటీ పెరుగుతుంది? బికాస్ దెర్ ఈజ్ ఏ ప్రెషర్ డ్రాప్. VR2 is greater than VR1 in the moving blade. So answer is only A is true. Source is Pekenog power plant engineering, 7th chapter, 3rd topic. Okay. Only this turbine is also called as the Parsons turbine. Find the correct pairs. Mach number compressible flow correct. Mach number is correct. Nusselt number boundary layer flow, that is also correct. Free surface flow Weber number, that is a ratio between the square root of inertia force by inertia force divided by surface tension force, that is also correct. But the second one, Reynolds number, that is also correct, but he has given the option ACD. All the four are correct. Whenever there is a fluid flow is happening inside a pipe, Reynolds number, which is defined as the ratio between the inertia force and the viscous force, if Reynolds number is less than 2000, which is also called as the lower critical Reynolds number, and if Reynolds number is greater than 4000, upper critical Reynolds number. Here the flow is called as laminar. If the flow is less than, if the RE is less than 2000, if RE is greater than 4000, that is upper critical Reynolds number. Upper critical Reynolds number, the flow is turbulent. Ante edaina incompressible fluid flowing inside a pipe, the flow would be laminar if the Reynolds number is less than 2000. This is formula is VD rho by mu, where D is the diameter of the pipe. D is the diameter of the pipe. So Reynolds number flow through pipe ki correct matching. So correct option is ABCD. అన్నీ కరెక్టే, కానీ వాడు ఆప్షన్స్లోనే రాంగ్ ఇచ్చాడు. ACD అని కరెక్ట్ ఇచ్చారు. ఓకే, ఫైండ్ ది కరెక్ట్ పేర్స్, విచ్ మీన్స్ దట్ he is mentioning that B is a wrong option. In the options లో మనకి ఏం తెలుస్తుంది, B అనేది రాంగ్ ఆప్షన్ అనే కాన్సెప్ట్ వస్తుంది. కానీ యాక్చువల్గా రేనాల్డ్స్ నెంబర్ ఈజ్ అప్లికబుల్ ఫర్ ఫ్లో త్రూ పైప్ ఆల్సో. రేనాల్డ్స్ నెంబర్ అప్లికబుల్ ఫర్ ద ఫ్లో ఓవర్ ఫ్లాట్ ప్లేట్స్, రేనాల్డ్స్ నెంబర్ అప్లికబుల్ ఫర్ ద ఫ్లో త్రూ పైప్స్ ఆల్సో. Okay, so the options are wrongly set. Okay, this is also correct statement. B also correct. I am telling the source now. Question number 51, source is Modi and Seth. Modi and Seth, one of the prominent book in the fluid mechanics, FM fluid mechanics. Modi and Seth, page 457, chapter incompressible flow through pipes. Incompressible flow through pipes. In fact, immediately after the Reynolds experiment, you can see this Reynolds experiment figure, this particular topic you can see in that page number 457, incompressible flow through pipes. ఆ చాప్టర్లో మనకి క్లియర్గా దీని యొక్క డెఫినేషన్ తెలుస్తుంది. అంటే ఈ క్వశ్చన్లో రేనాల్డ్స్ నెంబర్ ఈజ్ అప్లికబుల్ ఫర్ ద ఫ్లో త్రూ పైప్స్ ఆల్సో. కానీ వాడు ఈ ఆప్షన్ ప్రకారం ఏమైంది, ఏసీడి ఈ మూడే కరెక్ట్ అని చూపించాడు, రేనాల్డ్స్ నెంబర్ రాంగ్ అని చెప్తోంది ఆప్షను. సో బట్ బి ఈజ్ ఆల్సో కరెక్ట్, బి ఆల్సో కరెక్ట్. సో యూ కెన్ ఛాలెంజ్ based upon this data. Modi and Seth, fluid mechanics, page number 457 in the chapter incompressible flow through pipes. Okay, after the Reynolds experiment, you will see this topic in the textbook, Modi and Seth, very prominent book in the fluid mechanics. Find the correct pairs, he is telling. Friction independent of load. Actually that is it is a wrong statement. Okay, he has given only C and D. Actually the A is also, it means that, look at that, friction is independent of load. Friction increases with increase in temperature. Find the correct pairs he is giving. Okay, actually in this question there is a lot of ambiguity. If you just look at this statement A, in his mind, paper setting mind లో ఏముందంటే ఫ్రిక్షన్ అనేటువంటిది కోఎఫిషియంట్ ఆఫ్ ఫ్రిక్షన్ ఈజ్ ఇండిపెండెంట్ ఆఫ్ లోడ్ మ్యూ. సపోజింగ్ వి జస్ట్ టేక్ ఏ లోడ్, వెయిట్ ఈస్ కెప్ట్ ఆన్ ఏ సర్ఫేస్, సో దెర్ ఈస్ ఏ force of friction is applied load P. The limiting force of friction is given by mu into Rn. This normal reaction Rn depends upon the load. W is load here. లోడ్ కనుక ఎక్కువ ఉన్నట్లయితే నార్మల్ రియాక్షన్ కూడా ఎక్కువ ఉంటుంది, నార్మల్ రియాక్షన్ ఎక్కువ ఉంటే ఫోర్స్ ఆఫ్ ఫ్రిక్షన్ కూడా ఎక్కువ ఉంటుంది, ద లిమిటింగ్ ఫోర్స్ ఆఫ్ ఫ్రిక్షన్ కూడా ఎక్కువ ఉంటుంది. సో ఫ్రిక్షన్ ఈజ్ ఇండిపెండెంట్ ఆఫ్ ది లోడ్ అనేది, that is a dependent on the load. Okay, and if it is a coefficient of friction, F is equal to mu is independent of load, because mu depends only on the pair, ఏ మెటీరియల్స్ పెయిర్ ఉందో దాని మీద డిపెండ్ అయి ఉంటుంది. అంటే ఈ క్వశ్చన్లో ఉన్న ambiguity చూడండి, I'm talking about the first option. There is an ambiguity. If you talk about the coefficient of friction, it is independent of load. If you talk about the frictional force, then it is dependent on the load. So there is a lot of ambiguity. Friction independent of load ఇచ్చాడు. ఎప్పుడు friction independent of load? Coefficient of friction అయినట్లయితే. అదే కనుక frictional force అయినట్లయితే that is dependent on the load. So there is an ambiguity in the question. Ambiguity in option A. There is no clear mentioning in the first option. If it is I repeat once again, if the coefficient of friction mu, it is independent of the load. Coefficient of friction mu, it is independent of load, whereas the friction force, as you see from this, ఈ W కనుక ఎక్కువ ఉన్నట్లయితే నార్మల్ రియాక్షన్ ఎక్కువ ఉంటుంది, అంటే లోడ్ ఎక్కువ ఉంటే నార్మల్ రియాక్షన్ ఎక్కువ ఉంటుంది, నార్మల్ రియాక్షన్ ఎక్కువ ఉంటే లిమిటింగ్ ఫోర్స్ ఆఫ్ ఫ్రిక్షన్ కూడా ఎక్కువ ఉంటుంది. సో I can say you can challenge the question based upon the ambiguity in the question. If it is friction force, then fine, yes, it is dependent on the load. If it is a coefficient of friction, it is independent of the load. So people may take any way. So that way there is an ambiguity in the question. The source is, I am giving the source for this A.K. Thayal, textbook name is A.K. Thayal, Umesh Publications, Umesh Publications, in the chapter 6.3, 6th chapter, 3rd topic, 4th edition, A.K. Thayal, 4th edition. Source is A.K. Thayal, 4th edition, Umesh Publications, in the 6.3, 6th chapter, 3rd topic. It is the 4th edition. I repeat once again, A.K. Thayal, Engineering Mechanics. Textbook name is Engineering Mechanics. A.K. Thayal, Umesh Publications, 6.3, 4th edition. There clearly this figure is given. So once again I repeat, if it is a coefficient of friction, it is independent of load. If it is a friction force, it is dependent on the load. So it means there is an ambiguity in the question. Student may think anyway and keep the answer. So you can definitely challenge this question based upon this source. 76th question, internal combustion engines work on open cycle. Yes, correct, because working fluid will go into the machine and exhaust gases will leave out from the machine. There is definitely, it is open cycle. Option B, one of the assumptions of air standard cycle is that one of the processes that make up the cycle is irreversible. Actually, if you just look at the Otto cycle on the TS diagram, isochoric compression, constant volume heat supply, isoentropic expansion. It is an isoentropic compression, constant volume heat supply, and isoentropic expansion and constant volume heat rejection. Then the question comes, is the Otto cycle internally and externally reversible or not? Then the question is Otto cycle totally reversible? Totally reversible means internally reversible and externally reversible. Actually, definitely I can say only Carnot cycle is internally and as well as externally reversible cycle. Therefore, Otto cycle is not totally reversible. Why? Because only Carnot cycle, which looks like a rectangle, temperature entropy diagram, this is totally reversible cycle, Carnot cycle. Otto cycle is not totally reversible cycle. So one of the assumptions of air standard cycle is that processes that make up the cycle are irreversible. It is an irreversible heat internally irreversible. Why it is internally irreversible? The temperature of the working fluid is increasing. A process can be called as internally reversible only when it is isothermal. Isothermal process is internally reversible, like in Carnot cycle. Best example is Carnot. But is the process isothermal here? No, it is an isochoric. So it is not internally reversible. So that option B also correct. He has given only A is true. Option B is also correct. So I am giving the source for this. Sengil and Bowles thermodynamics textbook. Sengil and Bowles, page number 303, chapter 6. It is also McGraw-Hill. It is also, all the textbooks I am mentioning are McGraw-Hill except Modi and Seith. Modi and Seith is not McGraw-Hill. This is also Sengil and Bowles, MGH, McGraw-Hill Publications, in the chapter 6, page number 303. So what I mean to say here is, in the Otto cycle, you have two heat transfer processes. One is constant volume heat supply and other is constant volume heat rejection. Both are not internally reversible because temperature of the working fluid is changing. A process is called internally reversible only when it is isothermal, that is temperature is constant, like in case of Carnot cycle. Only Carnot cycle heat supply and heat rejection are reversible. So it is not totally reversible cycle. Definitely it is that assumption is wrong. So only A is true is given. Actually, both the statements are correct. Both A and B are true. Option is 1, but he has given the option as A. See, one of the assumptions of AERSEC, one of the processes that make up the cycle is irreversible. Yes, this is internally irreversible process. This is internally irreversible process. Why it is internally irreversible? Because the process is not isothermal. The isothermal process కాదు కాబట్టి ఒక్క isothermal process internally irreversible. ఇది isothermal కాదు కాబట్టి ఇది ఐసోకోరిక్. టెంపరేచర్ మారుతుంది. ఒక ప్రాసెస్ ఇంటర్నల్లీ రివర్సిబుల్ అని చెప్పాలంటే టెంపరేచర్ కాన్స్టెంట్గా ఉండాలి కార్నాట్ సైకిల్లో మాదిరిగా. కానీ టెంపరేచర్ మారుతుంది కాబట్టి డెఫినెట్లీ ఇట్ ఈస్ ఇంటర్నల్లీ ఇర్రివర్సిబుల్. సో దట్ అజంప్షన్ ఈజ్ ఆల్సో కరెక్ట్. సోర్స్ ఆల్సో had given. At higher loads in CI engines, the brake specific fuel consumption, it is a thermal efficiency, brake thermal efficiency of any CA engine or IC engine. It is given by 3600 divided by specific fuel consumption into calorific value. In CA engine or diesel engine, CA engine or diesel engine, CA engine or diesel engine, as load increases, brake thermal efficiency also increases. From the performance curves, brake thermal efficiency also will increase. As the brake thermal efficiency increases, therefore calorific value is anyhow a constant. Calorific value constant kabatti SFC ఇది పెరుగుతోంది అంటే SFC will decrease. So but he has given the answer wrong. Increases. The source will be Ganeshan, V. Ganeshan, IC engines. It is also Tata McGraw-Hill publication. Very famous man in IC engines. Ex-IIT professor, Madras. Late V. Ganeshan. In fact, he is in the internal combustion engines. You can see, check it that this is the source. Load పెరిగే కొద్దీ, load అంటే brake power. Actually, more correctly, load of the IC engine means its brake power output. As the brake power output, load on the CI engine increases, the brake specific fuel consumption BSFC will decrease. ఎందుకంటే థర్మల్ ఎఫిషియన్సీ పెరుగుతుంది కాబట్టి. CV అంటే calorific value of diesel, which is a constant. So correct answer is decreases, but he has given the option wrong answer, increases. I repeat once again, 4-stroke CI ఇంజిన్లో లోడ్ పెరిగే కొద్దీ దాని యొక్క బ్రేక్ థర్మల్ ఎఫిషియన్సీ పెరుగుతుంటుంది. You can even search in any Google also, I search. But this is a standard textbook that has given this source. V. Ganeshan, Internal Combustion Engines, Tata McGraw-Hill publication, TMGH. You can easily download that e-books in the Google also. Google Books also you can search. Okay. So that is a wrong option. You can definitely challenge. Arrange the following in the decreasing order of thermal conductivity. Clearly it is given that decreasing, what is చెప్పిన దాని ప్రకారం ఎయిర్కి థర్మల్ కండక్టివిటీ 0.263 వాట్ పర్ మీటర్ కెల్విన్. కాపర్కి థర్మల్, ఇది ఎయిర్కి, ఇది కాపర్కి థర్మల్ కండక్టివిటీ తెలుసా? 400, approximately 400 watt per meter Kelvin. Copper is a metal, great metal, conducting metal. వాడు ఇచ్చిన దాని ప్రకారం D is a decreasing order అంటున్నాడు. అంటే D అనేది B కంటే తక్కువ ఉన్నట్టు. Air is a very bad conductor. Air is a very bad conductor. The correct options I am giving, the correct decreasing order. C, diamond is highest 2300, then comes the copper, CD, then comes the aluminum, then comes the steel. ఆఖరణ ఉండేది ఇది కరెక్ట్ ఆప్షన్. This is the correct answer. ఈ ఆప్షన్ decreasing order of thermal conductivity. Diamond ki thermal conductivity 2300 approximately 2300 watt per meter Kelvin, all the units, K value. Okay. So the source I am giving it as the heat transfer, heat and mass transfer by Senjil and Ghazar, McGraw-Hill publications, McGraw-Hill publications, first chapter, very first chapter. first chapter, in the table 1, first chapter, he has given in that table, he has given all the thermal conductivity values. In that first table, after defining the Fourier law of thermal conduction heat transfer, Q is equal to minus Ka dt by dx. In that particular chapter, he has given all the values of the K for all the materials, gases, liquids, and solid metals, etc. Diamond is the highest conductor in that list. So, fourth is definitely a wrong answer. You can quote this source. What is the source? Sengil and Gazar. Textbook name is Heat and Mass Transfer, HMT. Sengil and Gazar, McGraw-Hill's publications, first chapter, table 1. You can take that table also. Wrong answer. 103 is wrong answer, definitely. In the chapter heat transfer. Textbook name is Heat and Mass Transfer, Sengil and Gazar, McGraw-Hill publications, first chapter, table 1. You can observe all the thermal conductivity values. Look at this, select the correct pairs. In the option C is, option C, look at the A and B correct is given, but look at the laminar flow over a flat plate. For laminar flow over flat plates, laminar flow అని ఎలా తెలుస్తుంది మనకి? The critical Reynolds number should be less than 5 into 10 power 5. First question కూడా ఆడు wrong option ఇచ్చాడు. Actually critical Reynolds number for flow to be laminar, this is the option, correct answer. So, ఒకవేళ laminar flow అయితే Nusselt number is given by HL by K is equal to 0.664 REL to the power of half, Prandtl number to the power of 1 by 3. Prandtl number అనేది ప్రాపర్టీ, అది వదిలేసేయండి. ఓకే, Prandtl number is given as mu Cp by K. అందులో డెన్సిటీ అనేది ఏముండదు. మరి ఇక్కడ డెన్సిటీ ఎక్కడ వస్తుందంటే ఇక్కడ వస్తుందండి, 0.664 V infinity L rho by mu. This is the definition of the Reynolds number, half into Prandtl number to the power of 1 by 3. ఈ ఫార్ములా ప్రకారం సేమ్ టెక్స్ట్ బుక్, what is the textbook? HMT, Heat and Mass Transfer by Sengil and Gazar. I am giving the page number also. Page number 422. 424, 7th chapter, second topic, 4th edition, Sengil and Gazar, 4th edition, heat transfer, 4th edition, Sengil and Gazar. Very famous book, Heat and Mass Transfer, HMT. ఈ ఫార్ములా చూస్తే మీకు డెన్సిటీ పెరిగితే as the density increases, H కూడా పెరుగుతుంది. You see, H is directly proportional to, from that formula, H is directly proportional to the density to the power of half. అంటే డెన్సిటీ పెరిగితే H అనేది పెరుగుతోందని. కానీ ఇక్కడ ఇచ్చినట్టు చూడ ఆప్షన్, laminar flow or flat plate mostly decreases if denser fluid is used. Wrong. As rho increases, H also will decrease. H also will, increase. But he has given the option decreases. Wrong option. C is a wrong statement. Okay. C is wrong statement. But actually, if you just look at this, convective heat transfer coefficient mostly decreases. He has given the A and B. The pressure gradient in the y direction negligible. So C is wrong. So pairing is, he has given the option, yes. Don't challenge this 122. Don't challenge actually, because he has given the correct option only. But mostly decreases, he said, but he has given the option. So C is a wrong statement. C is wrong. So 122 don't challenge, because he has given the correct statement only. I thought it is otherwise increases. Mostly decreases he has given, but in the option he has given AB. Boundary layer formed by uniform flow over a flat plate. Pressure gradient in the x direction is 0. That is a correct pair. Look, flow past a flat plate, pressure gradient in the y direction is negligible, correct statement. C is wrong. So A and B are true statements. C is a wrong statement, because according to this formula. So don't challenge the 122. I had wrongly put up this in this. 122 is don't challenge. Don't challenge 122. This is options are correct only, because C is also wrong option. And question number 47. In the question number 47, he has asked to calculate he has given the total barometric pressure, P absolute barometric pressure he has given. P barometric pressure is given, that is 760 mm, atmospheric pressure, more correctly P atmospheric pressure, that is 101.3 kilopascal. And he has asked to calculate what is the humidity ratio. Humidity ratio, that is W, or specific humidity, ఏదైనా అనొచ్చు, humidity ratio or specific humidity. W is equal to 0.622 into PV by PB minus PV. He has given the W, he has asked to calculate the PV. W is also given, W is given, but he has asked to calculate the partial pressure of water vapor. Partial pressure of water vapor in moist air. If you apply this formula in that problem, that answer is not matching. This is the formula. What is the formula for specific humidity? 0.62 into PV by PB minus PV, kg of water vapor per kg of dry air. So in this formula, PB is, we have to keep 101.3 kilopascal. Put W, W is given, I think W is given as 0.01 kg of water vapor per kg of dry air. I think I remember it is a 0.01. So definitely put this value, PB is 101.3, you will calculate PV, that will not match with the, you will get the answer in kilopascal, but multiply with 1000, you will get the answer in Pascal. In this question, it is not matching with the answer. Definitely we can challenge. The source for this formula is Pekenog Thermodynamics, 6th edition. The formula I am giving, the 6th edition, the formula also I am giving. 15th chapter, in the psychrometry, the chapter name is psychrometry, psychrometric relations. This is one of the very famous psychrometric relations. If you substitute that, if you substitute this W value, and if you keep the PB is equal to 101.3 kilopascal, you will get the PV formula. But to multiply with 10 cube, you will get the answer in Pascal, but that given options are not matching with this exact correct answer. So that you can definitely challenge this. Okay. Apart from this, there is a this is correct only. This is not, don't challenge. In which of the following process internal energy becomes equal to the heat transfer? Yes, this is correct only. In constant volume process, Q is equal to delta U. Don't challenge this. This is correct only. Yes, in the question number, there is one more question, that is 13. In the question number, before 25, there is question number 13 was given. He has given, he has compared about, definitely challenge this, question number 13 in fluid mechanics. He is talking about steady flow and uniform flow. Both the statements are wrong. Steady flow and uniform flow. Steady flow and uniform flow. What do you mean by steady flow? If the flow characteristics like pressure, density, temperature, etc. ఒక లొకేషన్ దగ్గర ఒక లొకేషన్ దగ్గర ఉన్నటువంటి ప్రెషర్ కానీ, వెలాసిటీ కానీ, డెన్సిటీ కానీ, టెంపరేచర్ కానీ ఇవన్నీ కూడా టైంతో పాటు మారనట్లయితే, చేంజ్ కానట్లయితే దాన్ని స్టడీ ఫ్లో అంటారు. యూనిఫామ్ ఫ్లో అంటే at any given instant of time, if you see the same velocity or same pressure between any two locations, దాన్ని యూనిఫామ్ ఫ్లో అంటారు. యూనిఫామ్ ఫ్లోలో వెలాసిటీ ఈజ్ నాట్ ఏ ఫంక్షన్ ఆఫ్ స్పేస్. స్టడీ ఫ్లోలో వెలాసిటీ ఈజ్ నాట్ ఏ ఫంక్షన్ ఆఫ్ టైం. ఓకే, బట్ రెండు స్టేట్మెంట్స్ ఆపోజిట్ ఇచ్చేసి కరెక్ట్ అని ఇచ్చాడు. ఛాలెంజ్ దిస్, డెఫినెట్లీ యూ మే ఛాలెంజ్ ది 13th question. 13th question in the fluid mechanics. The source also I am giving ఫండమెంటల్స్ ఆఫ్ ఫ్లూయిడ్ ఫ్లో అనే చాప్టర్లో మోడీ అండ్ సేత్ సోర్స్ ఇది. మోడీ అండ్ సేత్ ఫ్లూయిడ్ మెకానిక్స్ టెక్స్ట్ బుక్ ఇన్ ద చాప్టర్ ఫండమెంటల్స్ ఆఫ్ ఫ్లూయిడ్ ఫ్లో. అందులో క్లాసిఫికేషన్స్ ఆఫ్ ఫ్లూయిడ్ ఫ్లో ఉంటుంది ఆ చాప్టర్లో. వీ కెన్ డెఫినెట్లీ ఛాలెంజ్ దిస్. క్వశ్చన్ నెంబర్ 13. యాక్చువల్లీ ఆ రెండు స్టేట్మెంట్స్ కూడా రాంగ్ ఇచ్చాడు. హీ హస్ గివెన్ బోత్ ద స్టేట్మెంట్స్ యాజ్ రాంగ్. I'll just check it up. I'll read the statement here. I'll read the statement. The 13th question, what is given there. In the 13th question, it is given like this. Which of these two statements are true is given. Uniform flow is the type of flow in which the fluid characteristic like velocity, pressure and density do not change with the time at a point. It is a wrong statement. In the 13th question, in the question number 13, A is wrong, but he has given the A is true actually. Steady flow is the type of flow in which velocity at a given does not change with respect to space. It changes, space gurinchi kaadu maatladedi vaadu. He should be change, does not change with time. B is also wrong. So in the 13th question, definitely you can challenge with the source Modi and Seth fluid mechanics fundamentals of fluid flow chapter lonchi definitely 13th question challenge cheyochu. Okay, oka question challenge cheyoddu ani cheppanu. Actually in the list lo chusinatlaithe don't challenge this because this is a correct only. And one more thing also, don't challenge అని చెప్పాను. I am advising to challenge this question number 124 also. In an SI engine, the air fuel ratio remains close to the stoichiometric value from no load to full load. It's a wrong statement. In fact, stoichiometric air fuel ratio is 15:1. When the engine is operating under no load, it is called as an idling operation. Operating under no load condition is called as idling, no load condition. Okay, అటువంటి సందర్భాల్లో మనకు కావాల్సినటువంటి ఎయిర్ ఫ్యూయల్ రేషియో ఆల్మోస్ట్ 10:1 ఉంటుంది, near to 10:1. But there is a quite difference. In SI engine, air fuel ratio remains close to the stoichiometric value from no load to full load. Wrong option, but he has given all are true. Definitely can challenge this. But source I can say V Ganeshan, very standard book for IC engines. Source V Ganeshan, internal combustion engines. We can see because there are 4 operations in SI engines. 4 operations in SI engines. Throttling, under full throttle or middle throttling, idling, cold start, peak load and economy operation. So 4 different operations. Again repeat, cold start, idling, peak load operation, that is full load operation, and as well as best economy mixture, that is also called as the 16:1, where you get the maximum thermal efficiency. 4 operation ki 4 rakala air fuel ratios requirement untai. Peak load operation lo daniki kavalisiనటువంటి air fuel ratio 12:12.5:1 ఉంటుంది. Stoichiometric is 15, whereas no load దగ్గర మనకు కావాల్సింది 10. So different operations require different air fuel ratios, remains close అంటున్నాడు. Wrong option. Stoichiometric is 15 అయితే idling అంటే no load operation జరిగేది around 10:1 ఉంటుంది idling operation లో. So quite variation. You can check that air fuel ratios once again in the V Ganeshan. We can challenge that. Okay, 124 you can challenge. Which of the statements I have already said, uniform flow is a type of flow. A is do not change with rest. A is wrong. A is wrong. 13 definitely we can challenge. Steady flow is a B is also wrong. B is wrong. Both the statements are wrong. Source is Modi and Seth. Fundamentals of fluid flow. F fluid mechanics. Fundamentals of fluid flow నుంచి మీకు source అన్నమాట. source for challenging. Fundamentals of fluid flow. అది చాప్టర్లో మీకు అన్ని క్లాసిఫికేషన్ దొరుకుతాయి. యూనిఫామ్, నాన్ యూనిఫామ్, స్టడీ, అన్స్టడీ, 1 డైమెన్షనల్, 2 డైమెన్షనల్, రొటేషనల్, ఇర్రొటేషనల్ అన్నీ కూడా ఆ పర్టికులర్ టాపిక్లో దొరుకుతాయి. క్లాసిఫికేషన్ ఆఫ్ ఫ్లూయిడ్ ఫ్లోస్ అని ఉంటుంది ఆ చాప్టర్లో. అక్కడ దట్ ఈస్ ద స్టేట్మెంట్ వేర్ బోత్ ద స్టేట్మెంట్స్ ఆర్ రాంగ్ బికాస్ హీ హెస్ గివెన్ ఓన్లీ ఏ ఈజ్ ట్రూ. బి ఈజ్ ఆల్సో నాట్ కరెక్ట్. ఏ ఈజ్ ఆల్సో నాట్ కరెక్ట్. యూ కెన్ డెఫినెట్లీ ఛాలెంజ్ 13. Challenge it. In fact, here the answer is coming to be 0.5. The theory of machines, in the theory of machines, answer is coming to be 0.5, but he has given the answer as 1. In fact, in these statements which are given, instantaneous center regarding the theory of machines, only B is true. Only B is true. So you can definitely challenge this also. So I had given all the, in fact you can refer to the textbook, any Bhandari, Theory of Machines by Bhandari. Okay. Thomas Bevan, you can check this also. Thomas Bevan or Bhandari. In any of these books, these concepts are given. Only B is correct. Okay. So I had given the questions that can be challenged with sources as well. Good luck. All the best.